Conic equations, algebra 2, trigonometry regions. So what we're doing in this video is we're not going to be graphing anything. We're going to be given, an equation, and we're going to be asked, what is it? Is it a circle, a hyperbola, an ellipse, a parabola, a line? And so we need to be able to identify them. So first, a little bit of notes about each and how to tell. So this will be very handy. So a linear equation has 0 variables squared. And so that's the key. So when I look at something like this, I see an x squared, a y squared. So when you have 0 variables squared, and x and y are not multiplied, that's a linear equation. Like y plus x equals 7, or y equals 3x minus 4, stuff like that. That's a linear equation. There's another type of equation that has zero variables squared, and that's your inverse variation. But the key here is, for the linear, it said x and y are not multiplied. Well, for inverse variation, x and y are multiplied. And that's what really separates that apart. That's when you have something like x times y equals 4. And, we talked a little bit about this in the previous lecture, because this actually it's called inverse variation, but it's a type of a hyperbola. So when it asks for what type of equation this is, the answer could be hyperbola when you have an inverse variation. So hyperbola. So don't forget that inverse variation is a hyperbola. It's very different than the normal hyperbolas, but it is a hyperbola. But there's nothing squared, and x and y are being multiplied. A parabola is the only one that has a single variable squared. So if x is squared but not y, or y is squared but not x, then it's a parabola. The next 3 get grouped together because circle, ellipse, and hyperbola all have both variables squared. Both variables squared. Both variables squared. The key difference is that for a circle, they have the same coefficients. So if they have both variables squared, same coefficients, it's a circle. If you have both variables squared but different coefficients, then it's either an ellipse or a hyperbola. The key between these, both variables squared, different coefficients, the key here is the hyperbola has a plus between them. The ellipse has a plus between them, and the hyperbola has a minus between them. So you're really going to have to just take a look at each problem and then, at least in the beginning, go back to this list and kind of think about it. But after a while, I think you'll probably remember these rules. All right, so let's take a look at the first one. So graph of the equation, 4x squared plus 16y squared equals 25. So right away, I see I have x squared and y squared. That means both variables squared. So we're looking at a circle, ellipse, a hyperbola. Parabola doesn't make any sense because parabola only has one variable squared. Then I take a look at the coefficients. This one is a 4. This one is a 16. They are not the same. If it was 4 and 4 or 16 and 16, then it'd be a circle. But because you got different coefficients, now we're talking about the ellipse hyperbola. Different coefficients when both variables squared. Plus between ellipse, minus between hyperbola. The plus between tells me this is the graph of an ellipse. Number 3. Graph of the equation. So first thing I look for is what's squared. I have y squared, I have x squared. Both variables squared. That rules out the parabola. And a line if linear was a choice. But next here, I need to kind of get this in somewhat of a standard form. I don't want to have x and y on opposite sides. So let me bring the x squared over to this side, and I'd have to add x squared over to do so. And so now I see that, again, both variables squared, but this coefficient is 3, this coefficient is 1, so different coefficients, rules out circle. Plus between, this is, again, another ellipse graph. One more. xy equals 10. No variables are squared, so that means now I'm looking at either a linear or inverse variation, 0 variables squared. Are x and y being multiplied? This is x times y, not x plus y or x minus y. So x times y means this is inverse variation. And that is a form of a hyperbola. And so we have to remember that this is not what a standard hyperbola looks like. Let me jump ahead a little bit, actually, and find a hyperbola. Here you go. X and y both squared on number 6. Different coefficients. One's over 9. One's 1 over, the coefficient here is 1/9. Coefficient here is negative 1/16. So different coefficients, minus between. That's your standard looking hyperbola. But these, on number 4, these are also hyperbolas. They're inverse variation hyperbolas. So there's two types. Hyperbolas could be both squared or it could be neither squared. But they definitely need to be times each other if they're not being squared. And so we're just looking at the equation and consulting this list and thinking about it. Maybe we'll have to do a little completing the square to get standard form to compare and stuff like that. But it's not too bad. So that's as far as we're going to go in the video, and we'll just practice this tomorrow in class.